All right, let's get started. Welcome, everybody. Thank you so much for being here. I'm sure you've been to a lot of great sessions over the last couple of days. Hopefully, you're excited about the things you've seen so far. I'm excited about Windows 10 in general. My name is Karanbir Singh. I'm a program manager on the operating systems group. I specifically work on the authentication platform team that's part of operating system security. I'm really excited to be here today and representing all of the folks back home who've been working on a lot of cool things that we've done with Windows 10, and I'm really happy to be here today to show some of that to you. I know most of you in this room are developers. Clearly, you're into authentication, that's why you're here. But I would like to get a better sense of the spread in terms of what kind of services or apps you guys write, what identity providers you target primarily. So just a show of hands, folks who write or deal with apps or design apps that perhaps connect to Microsoft services or are relying parties of Microsoft identity systems like Microsoft Account or Azure Active Directory. All right, fair share. How about non-Microsoft identity providers? Oh, folks on video, there's no hands. I'm just kidding, a lot of hands. Finally, how many of you are in the business of providing these services? You are yourselves identity providers. I see a few hands, very cool. Or you own apps or suite of apps that perhaps you have your own specific identity needs that aren't met by off-the-shelf identity providers. So there's a fair share of everyone in this room. I think I'd be, given the show of hands, I'd be preaching to the choir if I highlighted the fact once again that authentication happens to be something that every app has to deal with in one form or the other. And our users are at a place where they expect amazing curated experiences that are personalized to their likings and their likes and dislikes. But they don't want to sign in to get those preferences. And the last thing they want to see is yet another login form where I have to enter my passwords, or even worse, sign up for a new account. The initial experience that an app has, the first 60 to 90 seconds, is so crucial to that app's success and destiny. And unfortunately, or fortunately, authentication happens to be a part of those first 60 seconds. So what I want to talk about today and really focus on over the next 45 minutes or so are to talk to you about some of the improvements we've made in Windows 10, specifically around the authentication platform, and then deep dive and give you guys an insight into the specific authentication features that are new in the platform, the infrastructure, the APIs that you can use in your apps, the APIs you can use in your apps to provide services to other apps, such that we are able to deliver those curated experiences that our users have grown to expect and will love once we deliver them. But before I go into that, I do want to take some time and just share with you some of the trends and just share some of the context in some of the background that as we were looking at what we wanted to do with Windows 10, that were critical design decisions that went into creating this infrastructure that I want to share with you today. There are trends that tell us today that a lot of people are working not only just at work, but virtually everywhere. How many of you send your first email way before you even make it into your workplace? All right, I would have expected all hands. I'll take about 90% of them. Last email way after you've left work. The point being, people are working wherever they can, be it on the road, in the air, cafes, on devices that they love. So the ubiquity of devices, my mobile phone in my pocket, my laptop, my desktop, all of these devices eventually are things that folks are using to access resources that they really want to get their hands on. Obviously, the ubiquity of these devices and the nature of the geolocations that folks are using these devices in is leading to software as a service, and it's obviously growing faster than we've ever known. People expect to have the ability to work when, how, and how they choose, using the devices they love and the apps they're familiar with. This isn't some small shift in the workplace. This is an entirely new business culture. The best way to adapt to these new needs, we have to just make it possible for folks to do what they're already doing in a much more seamless way. When we were thinking about what we wanted to do with Windows 10, this was at the back of our minds. With Windows 8.1, we obviously created the most personal PC ever. We reworked everything from the ground up, all the way down to the kernel, to all the way up to the user experiences, and delivered a really, really curated personal experience that over the last few years, we've learned that our customers like. Of course, there were a lot of things that they did not like, but there were also a lot of things that they did like. Things like access to the store, the applications they could download, the personalization, the start screen that was curated to them, the seamlessness that was available across devices, and all these personalizations were just roaming seamlessly wherever you wanted to access them. But when we started looking at Windows 10, we were like, all right, a lot of people are using PCs for work. Clearly, the foundation of how the modern worker works in a cloud-first, mobile-first world has changed. So what is it that we need to do, and how do we advance the platform from what we did in Windows 8.1 to the next version? And what we found was most of the services that folks really liked were all dependent on the availability of a Microsoft account, which was primarily a consumer-grade identity system. And all of the things that we wanted to make available, all of the things that truly light the Windows experience up, did not participate with a work or school accounts. You guys, I'm sure, went to the keynote yesterday where we talked about Azure and how successful it has been and how folks have written millions and millions of applications, their users, millions of applications. We have a very popular identity system in Azure as well, Azure Active Directory, as some of you guys know. But when we looked at Azure Active Directory and we looked at Windows 8.1, we found that, well, the two didn't really talk to each other, and they weren't exactly integrated. So that was something we wanted to address with Windows 10. So I'm happy to announce that Windows 10 connects to both personal and work clouds and provides a great user experience as well as a seamless developer experience. All the things that consumers grew to love with Windows 8.1, we brought that to Windows 10 for work and school accounts. I want to give you guys a little bit of insight about what I'm referring to here. So what we did was we revamped again the entirety of the Windows experience. So imagine you go to a retailer, pick up a brand new shrink-wrap device. You pick it up. You've seen this screen before in the out-of-box experience. We added some new flows right into the out-of-box experience. This particular screen, where who owns your PC, is a very, very interesting one. This is after lots of thinking and debates and going back and forth. What we wanted to do was we wanted to come up with the easiest question to ask consumers to express as to what it is that they were going to use this device for. Given all the trends that we're seeing, the bring your own device, the choose your own device, oh, come to my work, I'm going to hand you a device. Just bring your own device that you've been using. So, and it's very difficult to eventually ask, what are you going to use this device for? Because a lot of us do personal things on work devices, work things on personal devices. But at the end of the day, we landed on the best way to really understand what the intent of this device is and how a user expects to use it is based on, well, who owns it. And so right here, if a user goes ahead and chooses this device actually it belongs to my organization, it's a pivot for us to make following decisions on things like, well, all right, we understand what you're primarily going to be using this for, and what are some of the things that we need to do. So if you choose that, right from, again, the out-of-box experience, similar to how we used to have Microsoft account integration in out-of-box experience, here you can log in with your work or school account that are powered by Azure Active Directory. As soon as you enter your username, you get navigated to a tenant-specific. So in this case, since Bob at contoso.com was the account that was used to log in, the user was navigated to Contoso's particular tenant's webpage in Azure Active Directory, and it was possible for Contoso to brand this out-of-box experience. Now, in this case, this is very interesting where there are a couple of organizations. There's one set that is cloud-only, in which case we navigate to their cloud endpoint, and Azure makes it possible for you to brand that experience as you see here. So if I go back, there was a general screen which said, well, this is what you need to do on this screen, but as soon as you entered your password, things that IT pushed down, your branding, your logo, things like that, can be integrated right into the out-of-box experience. Now, if you were a federated organization and you had an on-prem existence as well, and let's say this device was on your premises, this would have seamlessly navigated to your on-prem authentication page. And now you have the ability, or organizations do, to add things like two-factor authentication and things like that. More interestingly, what we wanted to do was in order to bring the work productivity and use cases for customers to Windows, we also have to make sure that we bring all the expectations that IT has along with them so that they can control the devices and manage them and make it possible for folks to access resources. So it is possible for IT to integrate with a mobile device management solution of their liking. Again, if the account that I used to sign into this machine and back in the discovery phase, there was a mobile device management solution integrated with this particular account, the policies would be pushed down. Again, all of this is happening right in the out-of-box experience that a customer gets to see when they just go and buy a device from a retailer. There was an excellent talk yesterday on how to manage mobile devices and applications in the enterprise. So if you guys are interested, do check this out. Folks online as well, you could. I have links at the end of all the talks I'm going to refer to, and keep an eye out this blue little thing. So that will be my way of just letting you know what are the relevant talks you want to go check out. All right, so that's fun and games, great. So you were telling me that a user can pick up a brand new device and they can go ahead and provision it for the workplace. Okay, but what does that really mean? So I'm going to show you what that means. So let me switch over to a device here. So I'm actually going to use the example of my own account. This is a PC that I set up, having gone through the exact same process that I just showed you, and I used my credentials that I got from my workplace. Right from, you see the lock screen, it's personalized, it knows who I am. This is a brand new way of logging into Windows. So far, folks have been able to log in with a local account, with a Microsoft account, with an Active Directory account. Now, it's also possible to log into Windows with your Azure Active Directory account. So all those work or school credentials that you've been using to access the services you like, baked right into the operating system. Obviously, the true magic starts now. I've made it to my desktop. Now, can I get productive? So a lot of the things that we powered with Microsoft accounts in Windows 8.1, we've actually, like I said, brought them to 10 and made them work with Azure Active Directory accounts as well. So one of the applications that that helps me be pretty productive at work is the Word application. So this is an example of the Word Preview app that I got from the beta store. This is a universal Windows app that has been optimized for touch, works across all screen sizes, welcomes me. I can go ahead, read docs like an ebook. Now it's setting things up. This is the first time I'm ever using this application. So it's getting ready for all that stuff that it lets people do. Now this is pretty cool. It knows who I am and was able to welcome me. And I was like, all right, that's nice. And sorry, I don't want to pull that document. I clicked on the wrong document. But basically what it just did was that as soon as I said, all right, let's go ahead, you know who I am, it was able to pull down the last recently used document list that I have. Now, this is a curated list of all the things that I've been doing on various devices. So there was this one particular document that I was playing with, which is hosted on our work SharePoint, actually, that I was editing while I was still in my hotel. Word is accessing it, downloading it, and then, well, opens it up. The cool thing here is there have been no prompts yet. This application has been able to leverage the logged on user's identity to create a good welcome experience. But beyond that, it's been able to use the same user's identity to retrieve the necessary authentication artifacts to be able to talk to the services that lets it do the things it can do best. All right, other apps that make me, well, I use a lot, my mail app. This is another example of the same thing. It was able to just use my logged on user's identity, start syncing email. My calendar app, you get the point. Basically, all of these apps that were available in Inbox with Windows 8.1 have been updated to also work with your work identities now. I do want to highlight something else. So I set myself a reminder so that I didn't forget. So here I have an invite in my, on my calendar where I have a link. I'm going to click on this link. This link opens in Edge. I'm navigating to a link that was, again, hosted on a work SharePoint. I think I should have been on a faster network, but I just was able to access a resource in the browser that was hosted in a protected SharePoint, but once again, no prompts. So that's pretty cool. So as you can see, with Windows 8, we are bringing work and school accounts as a first-class citizen and lighting up all of those experiences that folks loved with Windows 8.1. Furthermore, we are making it possible for IT to have all the necessary controls they need in order to manage and deploy the services that they choose. The experience is pretty easy, so self-deployment is going to be really easy for consumers. The reason I'm telling you all these things is I just wanted to share with you all the things that have gone into Windows 10 and the identity investments we've made. So this is just one more avenue where we are targeting this market of workers, the modern workers, where we want to make Windows the most productive operating system ever. Another avenue to write those apps and get them into the hands of the consumer. Of course, platforms are great, but platforms are only as good as the experiences they light up. While identity plays a pivotal role in some of the things that I just showed you, the things that really matter are the applications, the verticals that we built on top of these identity constructs that eventually let users be productive. That's what it's all about. People want to get stuff done. We are in the business of enabling them to getting there. So as we were looking at identity and the investments we've made, obviously we wanted to make sure that we evolved the platform in a way where we made it possible and we created the right tools for you guys to integrate with, the right set of APIs, such that the experiences that I just showed you, it was possible for you to deliver even better experiences. And as we were doing that, we thought it was a great opportunity to just take a step back, zoom out, and not just solve the problem at hand, but take into consideration all of the feedback we've gotten over the last few years from developers. So thank you for all the feedback that you've been giving us. From identity providers, we've been working with a lot of them. And at the end, our end consumers. So the main set of challenges we found, well, one, pretty obvious. There was no Azure Active Directory on Windows, so there had to be a native way of doing things. Two, we had a few competing development models. If you were targeting Microsoft accounts, we had online ID authenticator set of APIs. Is anyone aware of those? Couple of hands. Then if you were targeting Azure Active Directory, we have Active Directory Authentication Library, which was an out-of-box library that was available for you guys to include in your apps. If you were targeting other third-party services, then we had the Web Authentication Broker APIs that have been hugely popular. But at the end of the day, all of them were very different APIs at the end of it, but trying to enable very similar use cases. And they had their shortcomings. We also heard from our partners where the APIs or the capabilities available in the platform weren't letting them really deliver the experience that they wanted to their consumers. And finally, all of these things led to pain, where users were having to enter their username and passwords all over the place. The experiences they were seeing with authentication login forms weren't that great. And so we figured, well, with all of these things, while we are bringing the new, let's bridge the old and make it all better. And that led to the birth of Web Account Manager. Now, this is primarily what I want to spend my time talking to you guys about today. The Web Account Manager is a brand new feature added in Windows 10. It is an authentication infrastructure that allows apps and services to request tokens and sign and be able to connect to services in a seamless way. It also enables identity providers or service providers to natively plug into the operating system and provide those services to other apps. So I'm going to give you guys a quick example. So what I'm going to do now is give you an example so that you get an insight about what I'm talking about. So let's look at some code. After that, I'll give you a little high-level overview of what's really happening under the hood, and then we'll go back and look at these APIs specifically. And what I'd like to do is just provide you with the functional behavior of these APIs so that when you download these samples and you start playing with them, you understand what's going on. All right. So let's switch over. All right. So here I have a very, very basic app. So one of the things I'd like to do as I'm going through these examples is focus on the act of getting a token so that you can talk to services, but not per se the process once you get a token and how do you talk to specific services. So I'll be focusing on getting the token part, and then I'll be pointing you to other really interesting talks that talk about specifically how you target these services that you want to talk to. What this app you see in front of you is pretty basic, similar to how you just saw the Office app. As soon as it was run, it knew who I was, and it greeted me. This application does something very similar. So the first thing, and in order to do so, what it's really doing is we've added a new API in the Web Authentication Core Manager, or the Web Account Manager namespace, which is Request Token Async. Request Token Async is one of the main APIs you'll be using a lot to request token, as the name suggests. In order to request a token, you have to construct a request parameter that you pass into this API. The request parameter actually takes in a few things. Things like, well, who the provider is, who do you want this token from? Things like, what is the client ID? What is the scope for which you want the token for? So the typical OAuth constructs. So you're requesting a token to be able to talk to a service, and you're saying, all right, please get me a token. I want it from this provider. Here's the client ID. So you can pass in a lot of the specific data that the various providers want. In my particular case, what I'm doing is, as you can see, I am targeting the Azure Active Directory provider, the Microsoft identity provider. So the first thing I do is get a handle to the provider. I use the API under Web Account Authentication Core Manager called Find Account Provider Async. You pass in the unique identity, the ID of the provider you're trying to target. And I'll go into the details of how this becomes more interesting. But for the time being, I'm getting back a provider that is a unique way to specify in my request as to who I'm going after. Then I go ahead and create the request where the web token request object takes in the provider, the scope, the ID of this particular app as it's been registered with the backend that I'm talking to, and finally the resource I'm trying to target. So in this case, what's going to happen is I'm going to request, as soon as I execute it, I'm going to request to get back a token to be able to talk to the resource, which is graph.windows.net. And after that, once I get this request, I'm going to just pass it into a welcome splash screen UI. Let's give it a go. I'm running on a VM, so things might be more slow than normal. But what you're going to see here, so by the way, what I forgot to mention was that I'm on the same device that I gave you the demo on where I showed you the various apps and I logged in with my Azure Active Directory. So what just happened here was I was able to use the same set of APIs and deliver the same great experience that the inbox apps just did. There were no authentication prompts. So this is new. On Windows 8.1, it wasn't possible to deliver a single sign-on experience using Azure Active Directory. The user had to at least authenticate once. But now, given that the user logged into the operating system with their accounts, it is possible using the new infrastructure for apps to be able to request tokens that map to it. Great. So let's switch back. I want to give you guys a little bit of insight into what's happening. One of the things that I want to highlight is that this infrastructure is not just geared towards Microsoft identities. This is an extensible infrastructure. So I'm just using the example of, and what I want to do is, because there are two audiences to Web Account Manager, the first one being the apps that want tokens, and the second one being providers that are in the business of issuing tokens. So I'm focusing first on the app side of APIs and the app side of things. And just to bring home the point using a first-party provider. So Web Account Manager is part of Windows. The actors involved are an application that wants to talk to an identity service or a provider. This could be one cloud. These could be many clouds. I've just, in order to make things look less complicated, I've just combined them in one cloud. And then there's the Web Account Provider. The flow usually is using the request token async API that I just showed you. You pass in the necessary context. Web Account Manager gets that request, processes it. The first thing it does is it figures out, do I already know about this account or this request in my cache? And if so, I'm just going to return it to you. This is obviously to make sure that performance is of utmost importance. Let's say there was nothing in the cache. The next thing it does is it breaks open the request that it got and looks at the provider that was passed in the request object and figures out whether a web account provider match corresponding to that ID was available on Windows or not. Another thing, before I keep going, I want to highlight. So here, app, the orange box, and Web Account Provider, the box at the bottom, they're just Windows universal apps. They're just apps. So after Web Account Manager is able to ascertain that, yes, I have this provider available, this app is installed. So what it does then is activates the corresponding Web Account Provider application and passes in all the context that it got from the original calling application, along with things like the package family name, so that the Web Account Provider has all the context. A couple of other things it does is it makes sure that the Web Account Provider is in the foreground, makes sure that all of the things from a windowing perspective and user experience perspective are done correctly so that you don't have to deal with it. Now, if this Web Account Provider, which is just an app, already knows who the user is, and in my case it did, in some cases, let's say you had an application, a third-party identity provider for that you have the app installed, and you'd previously just logged into that app because, well, you wanted to use it. In that case, no prompts. Obviously, all you see is an authorization to the request that you just made. But if not, the Web Account Provider can go ahead and authenticate the user, retrieve this token, pass it back to the Web Account Manager, where we put it in the cache just to make sure that the next time, if the same request comes in within a particular couple of seconds, we're able to hand this back really fast. We categorically did that because we wanted to make sure that this platform and this infrastructure scaled across the board. As you guys know, Windows is going to run on a lot of devices, all the way from really cheap phones to really expensive Surface Hubs. And the resources available on these devices are obviously really different. So we wanted to make sure that you, the app developer, didn't have to worry about how you were going to scale your apps to work on all these devices. We just inherently took care of how that would just work. So once we cached that token and the data that we got back from the Web Account Provider, we passed that token back to the application in the form of the request result. I'm going to deep dive into the request result and kind of crack open what is in this request result that's more than just the token. Eventually, the application uses this token and talks to the identity service. Oh, this is really funny. One of the PCs I was using to demo is installing the latest flight. That's fun inside our program. All right, so let's switch back to the demo. So now that you have a better understanding of what the web account manager does. So far what we've seen is, all right, I got a token this app did where I targeted a particular web account provider. Let's change the web account provider. Let's say you were writing an application that wanted to target Microsoft accounts now. So all I have to really do is go ahead and change the web account provider I'm targeting from organizations to consumers. Good. And this particular web account provider, I'm just going to change the request. So the same motion where the first thing the app has to do is find the web account provider, and then construct the request. In the request, as you can see, all I'm doing is passing in the provider, the scope. It doesn't take an ID because the Microsoft account infrastructure web account provider just works with the identity that was passed to it by web account manager. And in this case, by just making this simple change, when I run this app once again, it's going to take a while. The difference is going to be that a different web account provider that was targeted is going to launch. And the user can let me see if I have a faster computer for this. There you go. I see the Microsoft account authentication experience. I can go ahead and authenticate here. Once I do that, this app gets back a token. Let's click on sign in. Always happens. I am. Oh, this is funny. Oh, well. I probably crashed their servers with all the practices I was doing to make sure that this app would work on stage, and, well, my account's locked. But the point that I was really trying to make is that I could just easily retarget a different provider, change a couple of parameters where I changed who the provider I wanted to target was. I changed the request, because the request is always specific to the provider you're talking to. But from an infrastructural point of view, you were still creating, so the first thing you did was find a provider, second thing you did was create the request specific to the provider you were targeting, and finally used request token async as the API, right? So the example that I showed you was just using the same infrastructure, targeting a Microsoft account provider, and then talking to a Microsoft cloud. I want to deep dive into the various APIs that are available. And we can, you could download the samples, and obviously you'd be much happier playing with code to understand. But what I do want to do is introduce you to some of the APIs and the functional differences, and when you want to use one versus the other, and what are the subtle nuances involved. So the first one we talked about, request token async, you've seen. Takes a few parameters, like the request. The request comprises of provider, scope, client ID, and UI options. So if you want to, by default, we won't force a prompt. But it is possible for you to communicate to the web account provider that in my use case, I do want the user to once again re-authenticate. So this would be the case if you're writing an app that does a purchase, for example, and you want to really make sure that the user says, I really want to purchase, versus their kids just going trigger happy. So that's good. There's a second API called Get Token Silently Async. As the name suggests, this API by design is a silent API. So if you have a use case where you want to make sure that there's never any UI shown, or you're calling, want to request tokens from a worker or background thread, you want to use this API. The main functional difference, Get Token Silently Async, is you want to use it when you are absolutely sure you want to show no UI, so things you're doing in the background. Now, with request token async, there is a nuance. When your app calls request token async, there are two things that happen. The first thing that the system does, and you don't have to think about it, this just happens as part of the Web Account Manager doing its thing, is that it first tries to retrieve a token silently. So it checks the cache that we looked at. If the cache miss occurred, then it activates the corresponding provider in the background and says, hey, can you process this request? And that would succeed in cases where your app was previously authorized and the user has already authenticated. So in which case, well, you just get the token back without any splashes, without any screens shown. If all of that fails, then it activates the corresponding web account provider once again, but this time in the foreground. And therefore, it is after that where the web account provider can paint the experience that it so wants, which could be an authentication flow or an authorization flow or a two-factor auth flow. And the third API that's of relevance is sign out async. What sign out async does is when you as an app call for a request for tokens, you get back the tokens and some stuff. And I'm going to focus on the specific outputs also. But when you get back tokens, there's a trail that's created on the system. In the cache, the provider that's processing your requests also has to keep some data about who the requesting apps have been so far. So if you want to provide that functionality of a user wants to sign out of your app, you can use this API. What it does is it removes, for that particular application, any fragments that were created particular to that account. So that, I mean, this is important because let's say you were writing an application that is not just used by one user. It's used by many, many users, right? And it's running on a desktop that's a workstation, for example, and it's not personal. People come, use your app, log in, and then once they're done, they log out and they walk away. And then a second person comes in and logs in, and they go on. So this is when that comes in handy. What you don't want is for cached data to come back where you sign in not the intended user. So you want to use sign out async to cleanse any fragments that were created particular to this application that correspond to the account. All right, let's look at some of the response results. One of the main outputs of the API is the token request result. So this guy right here. And the request token, the token request result essentially is comprised of one main thing you're getting, which in turn has a few pieces of relevant information. Of course, we all know it has token in it, so I've already given that away. But the results are comprised of two main segments. The first is just data you get back, which has the token you requested, and secondly, a web account. A web account is a really interesting object, and I'm going to talk about that just in a little bit. And the second thing you get back from this request is the status. Now, the status is could comprise of two things. So as you can tell, if you requested a token for a web account provider and the web account provider wasn't available on the system, or the system crashed while processing this request, so there'll be a system result or error status that you get back. And assuming that the request made it successfully all the way over to the web account provider, but the web account provider had some specific result status that they wanted to provide to the application. So just to be very, very clear, an app makes a call, I want a Microsoft account token. We successfully make the call, go all the way to the web account provider, which is the Microsoft account provider. But the Microsoft account provider finds that, well, the user is in an interrupt state. They need to enter their password or their cell phone number once again for me to be able to process this request. So in that web token request result, you can crack it open. You can look at whether it succeeded or not. If it did, great, things are awesome. If they did not, then you can look at the specific error you got back from the web account provider and just paste it so that you know how to remediate it. I talked about the web account object, which is part of the response data. The web account object is essentially an object that corresponds to the user that you just got a token back from. What that means is a lot of times we find that we just want to get a token because we want to be able to pull some personalization details like their name, their picture, and things like that. So the web account object is an object that consists of all of this data that corresponds to this user that the token corresponds to. This is interesting because once you get this back, you can just crack it open, and if some of the information you wanted to get out of the user is just included here, you can go ahead and get it right from there. You don't have to make extra calls. But more importantly, for any subsequent calls you make, so the request token async API that we saw takes in a second parameter too. So we saw that there are two overloads to it. The first one was you pass in the request and you get back a token. The second overload is you can pass it a request along with this web account. And what that does is it is your way of communicating to the system that I just asked for a token once again for that user that you have previously given me a token for. Now, this comes in handy, especially when you're writing apps that deal with a lot of accounts, let's say a mail application. So what you end up having to do is for each account that a user adds, you have a corresponding set of tokens, and then you have to create a mapping of sorts, an indexing mechanism to make sure that subsequently when you're making more calls for refresh tokens or new tokens, that you have to figure out, well, user A, token A corresponds to this. So you create your own indexing mechanism. You don't have to anymore. You can just use the web account object and the ID that's specified in it, and just hang on to that ID. That's it. So when you get a token back, you get a web account. The web account has an ID. If you just hang on to this ID, there are other APIs available in the system where you can pass in. So you can do a find web account call on the web authentication core manager, which returns the web account that that ID corresponds to. That web account has all this information about who was the provider, what was the name of the user, what was the email address, things like that. And then you can use this web account object subsequently to make further requests. So it makes it really easy, and you don't have to recreate an indexing mechanism. All right. I want to highlight the fact that these APIs are in the Universal Windows platform, and they're available to both Universal Windows apps as well as classic apps. So if you own classic applications that want to target any of these identity systems, it is possible to use the same set of APIs to target them too. Now, some of you might be thinking, so you've just told me how I can request for tokens and target Azure Active Directory and get back those tokens, but what about Active Directory Authentication Library that I've been using so far? So I do want to make sure that I don't confuse you. So if your app targets Windows 10, you should use the Web Account Manager. This is the only way you get to, as it stands, to leverage the logged on user's identity and bootstrap your experiences based on how the user is using the device. If your app targets more than just Windows 10, perhaps down-level versions of Windows and other OSs, then you want to look at Active Directory Authentication Library because it provides a much more, the right tools for you to create those experiences. If you've written an app that uses ADOL and is deployed on Windows 10, it will continue to work. Right now, the Azure Active Directory Authentication Library is built on top of Web Authentication Broker, which is something that was introduced in Windows 8. Somewhere down the lane, we're going to switch the internal plumbing and switch over from Web Authentication Manager to the Web Account Manager. So from your perspective, things will you'll get an upgrade, so to speak. You wouldn't have to do anything to your app. It'll just work, and people will get single sign-on. Cool. If you want to learn more specifically about how to talk to Azure Active Directory, there's an excellent talk tomorrow that my friend Vittorio is giving at 9 a.m., so be sure to check that out. So this is where you found out about the new infrastructure in Windows 10, but when it comes to talking about specific services and connecting to them, this is a great talk that will shed light on how you can use Azure Active Directory and go through all the various configurations. There's also a talk, I believe this is tomorrow as well, around 3 or 3:30, where There's a talk on building universal Windows applications that connect to Office 365 services. So one of the things that so far we've seen, one of the things I want to showcase, just because we've made sure, and we've categorically, one of the main problems we saw was, and the show of hands too, not everyone's just targeting first-party Microsoft identity systems. People are also targeting third-party identity systems. So we wanted to make sure that we created an infrastructure where it was possible for third parties to integrate with Windows and deliver the same experiences that first-party identity systems with Microsoft have been able to. So Web Account Manager is extensible. Okay, let me see if the demo gods are with me. Give you an example of. Yeah, this machine's not, well, so far what we've done is we've talked about all the APIs that apply to the orange box, the app that's trying to connect to services and wants to request for tokens and then be able to talk to services. It's also, let's talk about the web account provider side of things. So far we've seen Microsoft provider and other providers that can plug in. But if you wanted to provide your own services, that you said, all right, well, I'm in this business and I want to go ahead and provide other apps and services, or apps, the ability to provide single sign-on in their own experiences without having to recreate the authentication logic, it is possible for you to add as many authentication web account providers as you want. This is really interesting. So you remember how I showed you when I logged in with my Azure Active Directory account? The first thing I did was obviously use an app that was able to single sign on. The second thing I did, though, was I clicked on a link that then opened in the browser, and it just worked. This was, I like to refer to it as browser SSO. This was something we introduced in 8.1 with Microsoft accounts. So if a user had logged into Windows 8 or 8.1 with their MSA, or even 10 now, not only would they get single sign-on when they were using apps, they would also get single sign-on in the browser, and specifically in IE when they were going to relying parties of Microsoft accounts like Outlook.com, for example. We've extended that functionality to work or school accounts, which is what you saw when I went to Edge, and I was able to open that PowerPoint document that was on my SharePoint. But what we've done is we didn't just stop there. We extended that support to all providers. So anyone who has a web account provider on Windows, which is just an app that's implemented the interfaces, it is possible for you to provide that experience not just to apps, but also to things that are running in the browser. And when I say browser, I don't mean just IE or Edge. I mean any participating browser. So why do you want to be a web account provider? This is not for everyone. If you're just writing apps that are relying parties to other identity systems, the first set of APIs that we saw are pretty good. Those are the ones you want to look at. But obviously, in order to create value for you guys to use those APIs, there has to be a corresponding set of web account providers that provide the services and the tokens that you're looking for. So if you're in the business of already providing identity services, this section is relevant to you. So there's that. You're already an identity provider, and you want to figure out a way to integrate with Windows. Second, if you find that you own a set of apps and services that want single sign-on, and then you have custom needs. So you don't want to have all of your apps implement something that's not replicated everywhere. You just want to have all of those apps leverage that logic in a single place, so you want a web account provider. Or thirdly, you find that the needs that you have aren't met by any of the out-of-box providers that you find out there, and you just want to write your own. So what does it take to write a web account provider? I'm not going to go into too many details. I will be hanging out at the Insider Lounge. So if this is of interest to you, definitely find me, and we can draw things out on the whiteboard, and I'll give you a better understanding. But it's pretty straightforward. The first thing you need to know is that a web account provider is just an app. It's a universal app, right? What that does is you can write it, you can submit it to the store, and folks can acquire it via the store. In order to become a web account provider, the first thing you want to do is register yourself as a web account provider. What that really means is in your app's manifest, there is a new extension category where you get to specify that you want to be a web account provider, and you specify your own unique ID. So if you saw those request token async calls that were taking in a provider and we were looking for a provider using an ID, that's where I got it from. So if tomorrow I created a Fabricam web account provider, I'll register it with a fabricam.com ID, which is unique to me, that then I can share with my application developers to use. A question I get a lot is, well, what prevents anyone else from claiming to be Fabricam too? So we've made sure that during store onboarding, we have the right checks in place where people can't spoof to be someone they're not. Second thing that you need to do in order to become a web account provider is handle activation kinds. So this is basically just all the functionality that corresponds to the APIs you've seen already. So there was a request token async API. Well, there's a request token corresponding activation kind. So when an app makes a call, Web Account Manager gets it, it activates the web account provider. And it says, all right, wake up. Someone just requested for a token. Please, can you go process it? So there are the two main classes of these activation kinds. One that is in the foreground, that is the web account provider's app comes up. And a great example of that is request token async. That might require a user to authorize or authenticate. There are other, one of the other things I didn't show you guys is the UX in Windows has also, we've gone ahead and updated the accounts UX in PC settings. So on this account, I logged in with my Azure Active Directory account, so that's what you see. And the only provider I had was, well, two. I had the work or school account providers, and I had my Microsoft account providers. Now, if I had a third provider, and I had gone ahead and added my account in a similar authentication flow that these were added in, that would also show up here. So Contoso, Fabricam, if you're writing your own web account provider, it natively plugs into the system and starts showing up under the accounts section PC settings. Things that users can do here are obviously remove the account and then manage it. So when clicking on manage, this would be another example of a foreground activation call now. So that's why I wanted to give you that context. So if a user goes ahead in PC settings, clicks on your particular account, and clicks on manage, we're going to activate the web account provider and say, hey, the user just clicked on manage. What do you want to show? And then there's the second class of activation kinds, which are primarily silent in the background. Get token silently async is a great example of it, where we activate you in the background and you're supposed to do your processing where you won't come to the foreground. And of course, the browser SSO that I alluded to. So if you're if you're a web account provider and you want to provide those browser single sign-on services, there are APIs that are available for you to push cookies in the right cookie jars that are brokered through the system. And finally, you want to manage the life cycle of this account. As part of a request token, you're woken up, the user authenticates, now you know who the user is. It is up to you whether you want to persist this account onto that system or not, in a way where it starts showing up in PC settings. So there's a corresponding set of APIs that are available for web account providers to do account management, where you can add a particular web account into the system, you can remove it, you can modify it, things like that. How many of you guys checked out the Microsoft Passport talk? Fair number. So all of the cool things that Windows 10 makes available in the form of Microsoft Passport are also things that you can leverage here. So if you want to provide that amazing facial recognition experience as part of your identity provider, this is the place you do it. You'd just be managing the request token in a way where you're leveraging the new APIs that do facial recognition for you. So all of because you're a web account provider, you're just an app, you have access to all of the rich APIs that Windows 10 makes available for you. There's also a talk tomorrow, which is on app-to-app communication. Now, this is interesting. So far, what we've seen is, a very rigid contract where apps want to request for tokens, and there's a bunch of back and forth. Once you're there, beyond that, sometimes you also have reasons where you want your app to talk to some other app for a completely different reason, or you want to share context for some reason. So this talk tomorrow at 3, where we talk about how apps can communicate with each other, is also really interesting. So something I would highly recommend for you guys to go check out. And using all of these things together, you can curate a really, really awesome experience for your end developers, and consumers. So just to wrap up, Web Account Manager makes it possible and provides native support for Azure Active Directory authentication on Windows 10. It makes it possible, all of this in a way where there are a simple set of consistent APIs that we just saw, where all you have to do is change the provider you're targeting and create the corresponding request. It enables, in the form of Web Account Provider integration, ways for Microsoft entities to also be able to play and provide the same level of support. So one of the things I really want to highlight is Azure Active Directory and Microsoft account flows that you just saw are built on top of this infrastructure. And all of the things they were able to do is possible for you to also provide as part of being a web account provider. And finally, all of these things, we hope that users will see less number of username and password prompts, and hopefully we'll get that single sign-on across a suite of apps where we deliver that value that folks expect that I talked about earlier. So with that, I'm going to open and take a couple of questions if you have any. Yes, sir. Sure. The question was, when you're writing a provider, is it possible for you to leverage another web account provider or not? And the answer is absolutely. Because in that case, your web account provider just acts as a relying party, just an app to that web account provider. So it is possible for you to chain web account providers. So you could do things like, well, I'll take a dependency on XYZ web account provider for, let's say, authentication purposes, but for authorization, I have my own custom logic. And that's what I want to bake into my custom web account provider. So that's possible. Yes, sir. Oh, great question. So the question was, I talked about browser SSO. Are there any JavaScript libraries for all of this magic to happen? So the browser SSO is interesting. So from a relying party perspective, so if you're just a web page that depends on an identity provider to be signed in, you don't have to worry about it. Things work exactly how they did, which is you use typical OAuth. A relying party navigates to the identity provider's web page, and if the user was already signed in, things happen, right? So from a relying party point of view, nothing changes. Web remains the way it does. From an identity provider point of view, things change slightly. There are two models if you want to understand browser SSO. And by the way, I'd be more than happy to talk about this in more detail when we talk in the Insider Lounge. But with browser SSO, there are essentially two models. The first model is the push model, where the web account provider can push cookies into the corresponding cookie jars via a web account manager, right? So this would happen when, let's say, the chronological order of things was the user has never gone to hotmail.com in his life using a browser. The first thing he or she did was use an app that was an authentication, that was authenticating using Microsoft account. And I was, let's say, for the sake of this example, on a local device. So no accounts known anywhere. The app is launched, does a request token async. Web account provider is launched. Since it didn't know who the user was, the user went through the authentication flow. Once the user authenticated, the token was generated and sent back. So that takes care of the app flow so far. But in parallel, what the web account provider also does is retrieves the right cookies from its backend, and then using the web account manager APIs, pushes these cookies via a brokered channel into the relevant cookie jars. So that's the push model, where the web account provider pushes things into the cookie jar. Now let's reverse the chronological order of things. The user never went to apps. The first thing they did was they went to the browser. In that case, it is possible for the web account provider's web page, in this case, to leverage a new protocol handler we've added in Windows 10, which is a TB auth. All of this information is going to be available in the resources I share, where there's a new protocol handler available. So on your web page, you could have a JavaScript that makes a call to this protocol handler. This is very similar to how you would do mail to or open a particular app. It's just one more whitelisted protocol handler so that there are no more links. So the JavaScript on the web page makes a protocol handler call, TB-auth, and then passes in context. That comes to the web account manager. We crack open the context and the request that we just got from the web account provider and figure out if this request is a valid one. And, well, who are you trying to target? I see a couple of faces that I just lost. Let's take an example. So let's take an example. Let's say hotmail.com. I went to hotmail.com for the first time on a local machine that has no knowledge of my Microsoft account ever. And whenever I use Microsoft account or hotmail.com, please feel free to swap it with anything you like, third party, first party. I went to hotmail.com. Clearly, I've never seen this user before. The user authenticates. Once the user authenticates, life goes on as it did. The right cookies are generated, how the web works. But in parallel, what they can do is, using the TB-auth protocol handler, they can say, all right, dude, can you pass these cookies that I just generated or this authentication artifact onto my corresponding web account provider? So they can do things like TB-auth, login.microsoft.com, and here's some stuff. Then we get that call, we process it, so we get a call saying, hey, someone wants to push data to the login.microsoft.com provider, and here's the data. If it comes from the right entity, we go ahead and activate a background activation in this case, where the web account provider is activated in the background, and we pass the context that we received from the web page. So that's basically how the browser SSO model works. All right. So I'll take one more question, and then let's talk in the Insider Lounge. Yes, sir. I'll talk to you. I'll find you.
So say you were a third-party two-factor authentication company. How would you use it? Is this something that you could use to use one of those services?
Absolutely. So the question was, what if you are a two-factor auth company, and can this infrastructure be leveraged? At the end of the day, as you saw, the web account provider is where the authentication happens, and that's your target audience, right? That's where you want to integrate with other your two-factor authentication scenarios. So you want all potentially web account providers to be talking to your service to provide two-factor auth services. So what you want to do is you want to go ahead and target all of the guys who are writing web account providers for Windows and go and pitch your set of APIs or services as an option if you want to just provide single two-factor auth without having to worry about it. So it'll be the web account providers of the world that would be the biggest bang for your hit, for your money, just because they're the conduit for a lot of applications to go through, as opposed to targeting each and every application and having them integrate with you. So it would be the web account providers that you want to go talk to. All right. Thank you, ladies and gentlemen. I am going to be hanging out at the Insider Lounge, so please feel free to find me.